So in our next section here, we're now into the CLI. Let's go ahead and make sure that we have just one IGP that's running in the core. So this is going to be ISIS routing. And then we're going to see how this is tying together for the end-to-end data plane for the customers. Okay, simple way I'm going to do this is on the other routers, which are router 2 and XR3, I'm just going to get rid of their OSPF process. Show run pipe include OSPF is no router OSPF 1. Okay, on XR3, likewise, I'm going to show run pipe to include OSPF. This is no router OSPF. Oh, I want to say it's 1. Let me make sure it's not the customer's process. Let's just say show run. Okay, so show run. And which one is the VRF aware process? OSPF 100, I believe, is for the customer. Yes. No, this one here, yes. Okay, so that one I don't want to delete. This is the one I want to get rid of here. Okay, but also I want to grab this. Okay, I want to grab its interfaces. I'm going to take this and I'm going to drop it into my notepad. Okay, so this is who? This is XR3. Okay, so on XR3, we go to global config, no router OSPF 1, commit the change. Okay, so we're not running IGP in the core for OSPF. This ultimately means that the final end-to-end customer traffic is no longer working. Okay, let me cancel this timeout 0 ping. We'll leave this as just a regular ping. Okay, we see right now connectivity is broken. Of course it's broken. I turned OSPF off, right? Okay, so we need an IGP. That hopefully is self-explanatory. In the core, I cannot route packets in and out an interface unless I have an interior gateway protocol. No, you cannot route the network alone in BGP. Look at me. I tried to do it the other day. It's nearly impossible. You have IGP. Regardless, you have either OSPF or you have ISIS. So the question becomes, do I need LDP? The answer is now, no, you don't, because you already have a control plane running. Okay, that's what ultimately we're doing here. We're replacing LDP with ISIS itself. We're already running ISIS. Makes total sense, right? Okay, so let's go ahead and copy this config. We look at XR2, we show run. We're going to look at what is it doing under ISIS. Okay, because today's class is not about ISIS routing, it's about segment routing, right? Okay, so what I need to do is I need to grab this router ISIS, and we're just going to expand it. Okay, so globally here, likewise, no router OSPF 1. Okay, we're not running 2 protocols in the core. Doesn't make sense. That was only for complexity of this design. I'm simplifying it now so we have one control plane. Okay, XR3 is going to have this node identifier or network entity title for ISIS. We don't need to do any fancy redistribution, Brian. We're not playing CCIE loop prevention today. We're playing LDP. So we need to do what? We need to turn ISIS on. We need to run LDP. We need to enable ISIS on the loopback. We need to enable it on the physical interfaces. In my case, these are my physical interfaces. They're not these ones that I copied from the other box. It is these values. So under that interface, and that interface, I'm going to be running address family IPv4 for ISIS. Okay, technically we're also running IPv6 routing, we can see there, but in my case it doesn't even matter because segment routing is independent of that, at least for this discussion. Okay, someone asked that. Are we talking about SRv6? No, not yet. We need to talk about segment routing in general before we can talk about, well, what else could you do with this? Aha, maybe we could use the IPv6 data plane itself. That is a brilliant solution to the problem, but we'll come back to that later. Okay, so what I'm trying to do here is to paste in ISIS. I believe that's my correct syntax. But luckily, if it's not in iOS XR, I could do what? I could roll back. Commit the change. Hopefully everything is fine. Okay, same thing with XR2. I'm now going to go to its ISIS process it already had running, router ISIS. And the interfaces that were previously in the OSPF process, which specifically, what do I care about here, is going to be 212 and what? 212 and 1213. Okay, 212 and 1213. Those are the interfaces that I need on this router to now participate in ISIS routing. Okay, so let's go to global config, router ISIS1. We go to the interface. Okay, just paste those in. Okay, so that interface. And then my wife is live tweeting me right now, guys. This is funny. Okay, so what is next is the address family. Okay, address family, IPv4 unicast, IPv6 unicast. Then that happened on gig 2.12. And commit. She's literally joking to me yesterday. She says, the only way I'm ever going to be able to get a hold of you now is on Twitter. I'm going to create an account and just follow you. That's literally what she's texting me. It's messaging me, hey, Brian, we're at the Paint by Penguin place. Come by with the kids. I'll be there, Jessica, in 30 minutes when I'm done telling everybody about segment routing, right? Okay, so let's commit our change. And let's see what did change. Okay, hopefully we have IGP reachability now. So I'm going to go to XR1, show IP route for 13.13.13.13. I have the route. Can I ping 13.13.13.13? Source is 11.11.11.11. Yes, I can. Hopefully this now fixed the end-to-end data plane. Yes, it did. So next, what did it really do though? Okay, what really happened is that I advertised my loopback. I advertised my loopback to XR2. Show IP route 13.13.13.13. I'm learning an ISIS route for this, but I'm also running LDP. If we show MPLS LDP interfaces, we see that LDP is enabled on gigabit 0000.1213. So, in other words, I'm learning the IP route on that interface. MPLS is enabled. It means I should look at the MPLS forwarding table. Okay, in order to populate the MPLS forwarding table, how did we do this? We had MPLS LDP bindings. Show me the binding table. The binding table says that your neighbor 13.13.13.13 told you if you want to reach the actual route 13.13.13.13/32 that you need to use implicit null. What does implicit null means? It means that that's my route. I advertise you my loopback. I give you the label of implicit null. You send me the return traffic. You would always prefer to use the neighbor that is advertising you implicit null because it means they are directly connected to that destination. Or in other words, I'm the destination of the MPLS tunnel. Use me. Okay, so specifically, we gave this value 24004 to XR2. And if we were to now look at the capture in the data plane, we would see that this is used as the transport label in order to get to router 13. So from router 6, we're no longer pinging, we're doing a trace route. And hopefully we should see inside that trace route that, hey, what label number was being used? It was 24004. Because 24004 from a transport point of view tells us use that PE, which is XR3, to exit. This is what LDP did for us. Now the question is, well, what happens if we turn LDP off? This is where segment routing comes in.